All right, so let's look at, let's assume that we are, let's look at, assume that we are a CPU, so let's look at each stage of a load instruction. Right. So in the instruction fetch stage, we need to read something from PC, compute it to be PC plus 4, and write back, right? And then here, based on PC, we go to instruction memory to read a certain instruction and store the result in the instruction fetch and instruction decode register. So in the next stage, the instruction decode stage read the 32 bits from the register. And then, because there's a load instruction, so now the control signal has already know what kind of instruction this is. So it can assign the proper control signals. So this read register will be RS. This write register will be RT. For the execution stage, now, oh, by the way, in the previous stage, the immediate field in the instruction is also doing the sign extension, and the result is also stored in the ID/EX register. Okay? All right, so in the next stage, now the ALU reads the first input from RS, and it reads the second input from the immediate field, and doing the operation here. By the way, let me go back to the previous slide. So here, in fact, internally, the CPU, in fact, it reads both RS and RT. And so the RS and RT are all stored in this register. And the immediate field is also stored in the register. They are all here. So in the next clock cycle, the RT is also fed into these mux. And the immediate field is also fed into these mux. But the control signal decides this one should be passed. But RT is also like an input here, okay? All right, so ALU takes the input from RS and the immediate field and compute the result and store the result in this EX/MEM register. Next, for load instruction, we need to use the calculated address and go to the data memory to retrieve the data. Okay, so we retrieve the data and store the result in the MEM/WB register. And finally, it is written back to the register. Okay, so this is the entire process. Does that make sense? All right, quiz. Why splitting each instruction into multi-pieces? Why do we take all the effort to divide an instruction into multiple pieces? Because we want to do the pipeline. Okay, we want the instructions to release certain resources when after it uses it, we want it to be freed. Okay? So in that case, many different instructions can be executed simultaneously, although they are using different hardware components. So pipelining is in fact sort of like parallel processing, except that it's different in the sense that parallel processing, you probably have several different duplicated hardware. So they can be done simultaneously. But in our case, we only have single hardware. But they are shared by several different instructions. Because once you finish using the first part of the hardware, you release the resource, and the second instruction can use that resource. Okay, so that's the main difference between a pipeline and parallel computing. But they are sort of similar. They are similar in the sense that you can execute many different instructions simultaneously. But they are different in the sense that For parallel computing, you have multiple duplicates of the resource. For pipeline, you only have one set of resource. But you are using that set of resource, sort of, you use some scheduling such that you can use the resource more efficiently, more effectively.